In this video, I will discuss a JEE Advanced PYQ from the topic Work, Energy and Power. This question is based on the relation between the potential energy and the force acting on a body. The relation is force is negative gradient of the potential. This is the x component of the force. So if you take a gradient of this potential energy with respect to x, that will give the force in the x direction. Let me take this example, potential energy function. This is a positive x direction, and this is the variation of the potential energy as a function of say x. So at this point, the slope is positive, so the negative gradient, it will be negative, so force is negative, so it's towards the negative x direction. At this point, the slope is negative, so the force is the negative gradient, so the force is along the positive x direction. At this point, the horizontal line, the tangent, so the force is 0. So at this point, which is the minima point, the force is 0. So at all maximum and minima point, the force is 0. And if I consider this as a Earth surface, and these are some hills and valleys. Suppose I have a mass here, say at this height, and I leave it or release it. So it will go like this, it will come up with the same height, and it will go down. So it will keep oscillating between these 2 points. So I have a mass of this much total energy. So at this point, the potential energy is of this value. So the other forms of energy will be 0. That means the velocity will also be 0. After the force is acting downwards or towards the positive acceleration, so it will come down. So because the velocity here will keep going up until the velocity becomes 0 at this point. So you have a mass of this much total energy will now oscillate between these 2 points, back and forth. So if you have a mass of this much total energy, it will oscillate between these 2 points. It will go like this and then come back like this. So with this understanding, we'll solve this JEE Advanced question. This is the question, you can read it. A particle of unit mass is moving along the x-axis under the influence of a force and its total energy is conserved. 4 possible forms of potential energy of the particle are given in column 1. A and U0 are constant. Match the potential energies in column 1 to the corresponding statements in column 2. Column 1, potential energy U1, this is a function, U2, U3, U4, the functions are different. And column 2, the force acting on the particle is 0 at x equal to A. Statement Q, force acting on the particle is 0 at x equal to 0. Statement R, the force acting on the particle is 0 at x equal to minus A. So first 3 talks about the force at x equal to A, x equal to 0 and x equal to minus A. Statement S, the particle experiences an attractive force towards x equal to 0 in the region mod x less than A. Statement T, the particle with total energy U0 by 4 can oscillate about the point x equal to minus A. So you have to match the potential energies here with the corresponding statements here. And 4 options are given. You can pause and run this question. So option A, the potential U1 is U0 by 2 U0 by 2 1 minus x by a square and then full square. So we can try to plot this function u versus x. Just consider this inside function. It's a parabola. It's an inverted parabola. So, and this parabola will have roots at plus a and minus a. If you put plus a, it will become 1. So 1 minus 1 is 0. This is the x-axis. Minus a plus a. It's inverted parabola. So at x equal to 0, this will be 1. This is the y-axis. So if I call this as f1, so this is f1. Okay, and this will have a value at x equal to 0. This will be 1. So to get u1, I have to square this f1 and then multiply by u by 2. So when you square this positive, negative will become positive and 0 will be 0. So this thing will become 1 square and then it will become u0 by 2. Okay, and it's an even function. So this is u1. So this is the maximum point. This is the minimum point. At maximum minimum point, the slope is 0. So the force is 0 at x equal to 0, x equal to a, and x equal to minus a. So statement P, force is 0 at x equal to a, true. Q, force is 0 at x equal to 0, true. And statement R, force is 0 at x equal to minus a. So PQR is true. Statement is the particle experiences an attractive force towards x equal to 0 in the region mod x less than a, that's x between minus a and plus a. So between minus a and plus a, if a mass is here, it will move away. There is no attractive force. Mass capital will roll down and go away. There is no attractive force towards this origin. So statement S is false. Statement T, the particle with total energy u0 by 4 can oscillate about the point x equal to minus a. So u0 by 4 total energy. This is u0 by 2. So u0 by 4 will be here, somewhere here. So this much of total energy. So if the particle is here initially, it can oscillate like this between this point and this panel, and it will come back. Go like this and come back and go like this. So between these two points can oscillate. So statement T is also true. So AE will match with PQRT. So option D can be ruled out. Next is the function U2. For statement B, U2 is U0 by 2 x by a square. So U2 is a simple parabola, roots at x equal to 0. So this is U2. So here the slope is 0. So the force at x equal to 0 is 0. A will be somewhere here, minus A will be here. At A, the force is towards the origin. At minus A, the force is also again towards the origin. But here it is minus x direction. Here it is plus x direction. So P is false, Q is true, force is 0 at x equal to 0. R is also false, so Q is true. B will match with Q. And then statement is the particle experiences the attractive force towards x equal to 0. That is true. So in this region, we have minus n plus a mass kept here will come here. So there is attractive force towards this one. So as it crosses this one, again it will come back here. So there is attractive force towards the origin between these 2 points. So this is true. The particle thrown into U0 by 4 can oscillate about the point minus a. Energy U0 by 4 will be somewhere here. So it will oscillate about the point x equal to 0, not about minus a. So that is also not true. So only Q and S are true. Q and S. So it's option B. We can also check the matches for statement C and D. So right now also you can figure out the correct answer is option B, because B, QS is matching with option B. So the third potential U3 option C is U0 by 2, U0 by x by a square, that is same as U2 into this exponential of e raised to the power minus x by a whole square. So this is already U2 we have here, and we have to figure out how this function will look. So it's e raised to the power minus x by a whole square. So at x equal to 0, it is 1. This function, if we call it G3, and it will die down exponentially, and it's an even function. Plus x is minus x is the same thing, because minus x square is x square. So this is G3. So if I multiply these two, one function is increasing, another function is decreasing. So the product will attain maximum somewhere. So here it is 0, attain maximum here. After that, this exponential thing will dominate until tend to 0 at very large value of x. And it's an even function. U2 is even function, plus x and minus x are same. This is also even function, plus x and minus x are same. So the same thing will come here also. Somewhere there will be a maximum and then will die down. So this maximum point that we can find out by differentiating this one and putting it equal to 0. U2, it's x square. We can forget this constant to get this maximum point. So U2 has got x square, and then this thing has got e raised to the power minus x by a whole square. So let me call this function h3 of x. So whenever this thing is maximum, U3 is maximum. So this thing, the force is 0 at x equal to 0. And force also 0 at this point, but you have to find out the x coordinate of this place where the thing is attained maximum. So if you differentiate this one with respect to x, there will be x square derivative of this one, that's minus x by a whole square, and the derivative of this thing is minus 2x by a square. Minus sign is there, it's x square, derivative is 2x, a square is here, and then derivative of 2x is 2x into e raised to the power minus the same thing, x by a whole square. So this we have to put it equal to 0 to get this maximum point, and this is the minimum point. So this factor we can cancel, and then x can be cancelled, and 2 will also go. So this is x square by a square minus x square by a square. Everything has gone. So plus 1 equal to 0. So that means x equal to plus or minus a. So actually this maximum is happening at plus a and minus a. So the force is 0 at x equal to 0 and x equal to plus a and x equal to minus a. So all the three statements, first three statements, P, Q, R will match for this statement C. And statement S, the particle experiences attractive force towards x equal to 0 between minus a and plus a. That's also true. Between minus a and plus a, there's a mass will come towards here, and after reaching here will come here. So I'll state about this origin. So there's attractive force at x equal to 0. So PQRS. That's also true. Statement T, the particle has total energy U0 by 4 will oscillate about x equal to minus a. There is no oscillation about minus a because that should be a minimum point. So statement T is not true. So PQRS. So that's there in the option B. And option D potential is U0 by 2 into x by a minus 1/3 x by a cube. Basically, we should know how to draw this graph of different functions. Once we do that, we can also find the location of the maximum and minimum point using the concept that derivative is 0 at maximum and minimum point. So for this function, this is nothing but cubic function. This is cube. So x by a can be taken out into 1 minus 1/3 x by a square. So three roots of this one. One root is x equal to 0. Another one is x equal to plus or minus root 3a. So this is 0. The function is 0. This is u4. And x equal to root 3a. A will cancel. Root 3 square is 3. Similarly, minus root 3a. Here also the function is 0. And for large positive value of x, this term will dominate. So this is negative. So it will be here. So this is the point. And similarly for large negative, this is a negative quantity. And here is a negative quantity. This is a 0. This also is 0. This is 0. So there are three roots of this cubic equation. So the force is 0 at these 2 points. We have to find out where it is. reaching maximum. That we can find out by differentiating this one and putting it equal to 0. So if I differentiate this one, I'll just take this one and differentiate. So if we differentiate this one, term by term differentiation will become 1 by a, and then 1/3 a cube is a constant will come out, and then x cube will become 3x squared. So this is equal to 0. This value of x will correspond to this point and this point, and also this point. Okay, so a can be cancelled. This will become a square. 3 and 3 will go. So again, it will become x equal to plus a and minus a. So 2 points. The derivative is 0. One is the maximum point, one is the minimum point. So the force is 0 at x equal to a and minus a, and non-zero at 0. So force is 0 at x equal to a minus a. So P and R are true. P and R will match for option D. And the particle experience attractive force towards the origin at between minus a and plus a. Between minus a and plus a, if the particle is here, will come here, will go like this. It will not oscillate about this point, so that is not true. Statement T, the particle total energy U0 by 4 can oscillate about the point x equal to minus a. Energy of U0 by 4. So we can find this maximum value, the y value here. This is U4 at this point. What is this y value? So if you put x equal to a, this will become 1. So x by a is 1. So 1 minus 1/3, that is 2/3. So it's U0 by 3. To get the value of U4 at this point, put x equal to a, that's same as saying x by a is 1. So x by a is 1, 1 minus 1/3, 2/3, 2 and 2 will cancel, so it's U0 by 3. And the energy in statement T is U0 by 4. So U0 by 4 will be somewhere here at this level. U0 by 4. So the particle is here, it can oscillate about this point. So statement T is true for option D. Oscillate to minus a. But it's not a symmetric oscillation. So option B, D about PRT, C about will match with PQRS. So option B is the correct answer. That we can figure out from this first two matches itself, because the result will fix the answer as B. But for checking the full answer, we have done the remaining part. This is what I explained here. Option A, the function of the potential is of this form U0 by 2, 1 minus x by a whole square. So let me call this inner one as F1. It's a parabola, inverted U parabola. So F1 will look like this. It has got zeros at minus a and plus a. At x equal to 0, the value is 1. So if I square this F1 and multiply by U0 by 2, so it will look like this. The negative thing will become positive. So this is the variation of U0. So it has got slope 0 here at the maximum point and slope at 0 at minus a and plus a. So PQR is true because the forces at x equal to 0 and x equal to minus a and x equal to plus a are 0. And statement S, particle experiences attractive force towards origin. There is an attractive force towards origin because if it is here, it will move away from origin. So S is not true. And statement T, particle energy U0 by 4 can oscillate about the point x equal to minus a. So U0 by 4 will be here. So you can oscillate about this point. If it is initially here, you can oscillate like this. So T is true. So A will match with PQ or T. Option 2, the potential is of this form. It's a simple parabola. So the force is 0 at x equal to 0. At A and minus A and plus A, the force is not 0. So Q is true. P and R are false. Statement yes, there is attractive force towards the origin in the region x between minus A and plus A. So statement S is true. And statement T, oscillate about minus A. Minus A will be here. To oscillate about a point, there should be a minimum at that point. At minus A, there is no minimum. So T is not true. So B will match with Q and S. Option C, the potential of this form, U0 by 2 x by a square. This is the same as potential in the second option, U2. And that exponential term. This is an even function because plus x and minus x, so when you square it, it will have the same value. And this function will dive down exponentially. It's a even function, the same thing here. And this U2 is like this increasing function. So when you multiply somewhere, one is a decreasing function and U2 is an increasing function. So when you multiply increasing function, decreasing function, somewhere it will reach a maximum. And at large values, the exponential term will dominate. So that will make it 0. So to find the location where it's becoming maximum, that we can get by differentiating this thing with respect to x. So the thing that will matter is x square here and e raised to the power minus x by a whole square. So if you take this one x square and then e raised to the power x square by a square, if you find maximum and minimum of this function, that will give me the location of the maximum and minimum of u3. So differentiating term by uv rule. So 2x into e raised to the power this thing plus x square into derivative of this thing is e raised to the power whatever is there, and then 2x for this one. So if you put equal to 0, I'll get G3. I see what x equal to 0 and plus and minus c. So force is 0 at these 3 points. So force is 0 here, force is 0 here, force is 0 here. So PQR, R is true. Statement S, it will oscillate about the origin. There is attractive force towards the origin. Statement S is true. Statement D, oscillating about minus A. For that, there should be a minimum about minus A. There is no minimum of minus A. So T is false. So C will match with PQRS. Option D, the potential is U0 by 2 cubic function. So we can draw the zeros of this function, plot the zeros of this function. So if we take x by a outside, so 1 0 is x equal to 0. Another one is x equal to root 3a because root 3, a and a will cancel, root 3 square will become 3, so it becomes 0. And it can also be minus root 3, a. So the zeros are 0 plus root 3a and minus root 3a. And for large values of x, this thing is negative quantity and this is positive, so it will become negative, so it's minus infinity. For large negative value here, this thing is negative and this is also negative, so product is positive, so it's plus infinity. So the cubic function is look like this. So to find the location of this maximum, for that you have to differentiate this function with respect to x and put it equal to 0. So x by a, if differentiate, I'll get 1 by a, and then x cube will become 3x square. 1 3 will cancel, so just x square. 1 3 will cancel with this 3. So this will be x equal to plus or minus a. So at plus a and minus a, the derivative is 0. So one is maximum point, another one is minimum point. So the force is 0, minus a and plus a. So statement P and R are true. And force is not 0 at origin. So Q is false. Yes, there is no attractive force towards the origin. T, U0 by 3. For U0 by 4, the energy is somewhere here. So it can oscillate about x equal to minus c. If it is initially here. So statement T is true. So D will match with PRT. So the correct option is option B.